Yes, good day. So we are going to see about the DC circuit analysis. Under this DC circuit analysis, the topic for our today's discussion is mesh analysis. The other name of the mesh analysis is loop analysis. So the main instance for using the mesh analysis or loop analysis is to find the loop currents. In a circuit, if we are having multiple number of loops, for example, if we are having one source and there are 5 loops, what is the current that is flowing in the 5th loop could be found easily by using this mesh analysis. As far as the title is concerned about DC circuit analysis, the DC circuits are something which will be dealing only with resistance, and next one is your AC circuits are those which will be dealing with your resistors, inductors and capacitors. In the DC circuit analysis, you are going to use two prime laws. One is your Kirchoffs voltage law and second one is called as your Kirchoffs current law. As far as your Kirchoffs voltage law is concerned about, it could be defined as in a closed loop. In a closed loop, the potential rise is equal to the potential drop. The potential rise is equal to the potential drop. And as far as your Kirchoffs current law is concerned about, on a node, the sum of the incoming currents is equal to the sum of outgoing currents. This Kirchoffs voltage law is used by the mesh analysis. And the Kirchoffs current law is used by the nodal analysis. So let me go in thorough by taking up a problem to know better about the mesh analysis. So consider a bridge circuit. The bridge circuit will be having this resistance is called as your 2 ohms, and there is one another resistance which is called as your 6 ohms, and this resistance is called as your 4 ohms, and there is also one another resistance here. This is your 4 ohms, and the closing side of the loop is your 6 ohms. Now the mid resistance value is called as your 2 ohms. This complete circuit is energized by an voltage source which is 30 volts. Now what can we do with this circuit is, so in order to reduce the complexity of the circuit, we can redraw the circuit like this. So this is your 30 volts and this is your 2, this is your 6, 2, 4 and as well as your 4. As far as the solution for this circuit is concerned about, first what you want to do is you want to name this loops. So first loop, second loop and third loop. Secondly, what you want to do is you want to give the current direction for these loops. So whenever in any loop you have a source, always select the direction of the current flow is from positive to negative of the source. So if any loop you don't have any source, then you start the current from a node. Okay, and here also for this also you start the current from the node, and this is like this. So this current is your I1 and this is your I2 and this is your I3. I1, I2 and I3. Now how to write the equations for the first loop and as well as the second loop and third loop is, the law that we are going to use is your Kirchoffs voltage law. As far as Kirchoffs voltage law is concerned about, in a closed loop the potential rise is equal to the potential drop. So the potential rise is your 30 volts in the loop number 1. Potential rise in the loop number 2 is 0. Potential rise in the loop number 3 is your 0. So your I1, I2 and your I3. Your I1, I2 and as well as your I3. I1, I2 and your I3. First what we do is, let me find the values of the diagonals. In loop number 1, the I1 value is sum of the resistors in the loop number 1. So 2 plus 6 is your 8, 8 plus 4 is your 12. And in loop number 2, the sum of the resistors of the loop number 2 is 6 plus 6 is 12, 12 plus 2 is your 14. And in loop number 3, the sum of the resistors of the loop number 3 is 4 plus 4 is 8, 8 plus 2 is your 10. And next one is how to find the I2 and I3 for your loop number 1 is the first loop and between the second loop, what is the resistance? Between the first loop and second loop, the resistance that is present is your 6 ohms. So in 6 ohms, the I1 is a downward current, but whereas I2 is an upward current. So opposite directions, you write it as minus 6. So in the first loop, between the loop number 3 and loop number 1, the resistance that is present is your 4 ohms. So downward, and this is your upward. Both are in opposite direction. So you can write it as minus 4. You rewrite these two values here, minus 6 and minus 4, because this matrix is a completely invertible matrix. So now see here, loop number 2 and this is your loop number 3. Between loop number 2 and 3, the resistance that is present is your 2 ohms. So here the direction is like this and here the direction is opposite. So minus 2, and here also you can write it as minus 2. Now to find the I1, I2 and I3 value, what you want to do is you can use calculator very well to find the value. So how to find is, so consider first what you want to do is shift and as well as your mode. You want to reset everything. So 3, reset everything. And then next one is you want to do is in mode 3 times. So you are getting one equations. One is your equations. And how many unknowns you have? I1, I2 and I3. Now fix the unknowns to be 3. And here it will be asking about A1, B1 and C1. This is your A1, B1, C1, D1. A2, B2, C2 and D2. A3, B3, C3 and D3. So now upload the values, minus 12, minus 6, minus 4 and 30, and your A2 value is minus 6, 14 and your minus 2 and your 0 and this your minus 4, minus 2 and your 10 and your 0. Now the value of your I1 is 4.286 because you are rounding, and the value of your I2 is 2.143 and the value of your I3 is 2.143 and the unit for your current is your amps. So 4.286 is your I1 and 2.143 is your I2 and I3 value. Thanks.